If A is a constant vector, prove that curl of A cross R, A vector cross R vector, is equal to 2A vector. Suppose we take A vector equal to I cap Ax plus J cap Ay plus K cap Az, and R vector is I cap X plus J cap Y plus K cap Z. Then what will be A cross R? If you take the cross product of this A vector with R vector, then that can be written in, we know cross product can be written in terms of determinant, that is I cap, J cap, K cap, Ax, Ay, Az, Ax, Y, Z. If you find out the determinant, then you can, that will be the cross product of A cross R. So A cross R will be equal to, when you find the determinant, for I cap, you leave this column and this row. So Ayz minus Azy, this is Azy, plus if you, for J cap, you leave this column and this row, Azx, here Azx minus Axz. So Azx minus Axz plus K cap, for K cap, you leave this column and this row. So K cap will be, for K cap it will be equal to K cap into Axz. So for K cap you leave this column. So Axy, so Axy minus Ayx, so Ayx. So this will be the cross product of A cross R. And to find the curl of A cross R, you know curl of A cross R means the cross product of A cross R with the del operator. If you take cross product of del operator with A cross R, that cross product is a vector product, then that will give you the curl. And we know del operator is I cap partial derivative with respect to x plus j cap partial derivative with respect to y plus k cap partial derivative with respect to z. So if you find out the curl of A cross R, then that will be equal to I cap, J cap, K cap, partial derivative with respect to X, partial derivative with respect to Y, partial derivative with respect to Z. And for the A cross R vector, you have three components. For I cap component, Ayz minus Az Y, this one. And for J component, you have Azx minus Axz, this one. Azx minus Axz. And for K cap component, you have Axy minus Ayx. So if you find out the determinant, then you can, and that will be the curl of A cross R. So let us find out the determinant. To find out the determinant for I cap component, you have I cap, you leave this column and this row. So I cap into partial derivative of Axy minus Ayx with respect to y, this term, minus partial derivative of Azx minus Axz with respect to z, this term. And for jth component, you have plus j cap. So you leave this column and this row. You have partial derivative of Ay z minus Azy with respect to z, this one, minus partial derivative of Axy minus Ayx with respect to x, this one, plus for K cap component, you have, you see, for K cap component, you have this one, that means you leave this column and this row. So for K cap component, you have partial derivative of Az x minus Axz with respect to x, Azx minus Axz with respect to x, minus partial derivative of Ayz minus Azy with respect to y, this term. So you have three terms. And if you find out the partial derivative of this term with respect to y, the only you have ax for this term, because for this term you have no y, so that will be equal to 0. and for this term also it will be equal to 0, and for this term it will be equal to ax. So you have one x for here and another x here. So I cap ax plus ax. Similarly, for j term, you have partial derivative with respect to z. That means you have a term ay here, and for this term that will be equal to 0, and partial derivative with respect to x. For this term you have ay. So one ay here and another ay here. So you have ay plus ay. Similarly, for kth term, you have partial derivative with respect to x. That means here you have one az term here, and for this term it will be equal to 0, and for y term you have az, one az, and here for one az. So az plus az. So curl of a cross r will be equal to I cap ax plus ax plus j cap ay plus ay plus k cap az plus az. So curl of a cross r will be equal to 2 times. If you here ax plus ax 2ax, here ay plus ay 2ay, here az plus az 2az. So you take 2 common. So in the bracket you have ax I cap plus ay j cap plus az k cap. But we have taken ax I cap plus ay j cap plus az k cap is equal to a vector. So that will be equal to 2a vector. So in this way you can prove that curl of a cross r is equal to 2a.